A backing property is where two properties are conceptually the same, but one is part of the public API of a class and the other an implementation detail. A very common reason to do this is because you don't want code outside of the class to directly modify a property inside the class. So let's look at an example. Say that we are creating an app to manage our Kotlin New Year's resolutions. So these are commitments that we're making to ourselves to improve our Kotlin skills throughout the year. So let's create a class called resolutions repository where the resolutions will live. And inside that class, we create a property called resolutions, a mutable list of strings of the improvements we want to make this year. But we don't want code outside of the repository to just make changes to the resolutions. Only a resolutions repository should have that privilege. So let's do a few refactorings. Let's start out by renaming the resolutions property to _resolutions and making it private, so it's only visible from inside the resolutions repository. Next, let's create a property the clients of our class can use to get, but not set or change our list of resolutions. And we've just implemented a backing property. Do you see it? _resolutions is the backing property of the resolutions property. The type of resolutions is a list of strings, which is a read-only type. Say we thought of another good Kotlin resolution to make. Which property should I change? Resolutions or _resolutions? Let's create a function called add Kotlin in action in the repository. It will check that that resolution isn't already in our list. Otherwise, we can add it to the _resolutions mutable list. So the correct answer is, of course, _resolutions, since it is a mutable field. If you've been coding in Kotlin for a while, you've probably seen the concept before. I'd like to point out the flow cases where shared flow has mutable shared flow and state flow has mutable state flow as mutable types. But we could make the relationship between the two types for a property more explicit and clear by using the explicit backing field or EBF syntax. Before we get started, we need to enable this experimental feature like this in our project's build.gradle.kts file. Remember to sync Gradle. Let's go back to our Kotlin resolutions code. Let's comment out what we had so we can start afresh and still see what we coded before. So first we're going to declare the public part of the property with val resolutions and then the public type. Next, we are going to code the explicit backing field with the keyword field, and then we're going to move the initialization code we had before. Next, let's see how we can use the explicit backing field. First from its declaring scope to modify the variable, and then from some client code to read the variable. Let's edit the add Kotlin in action function we had before. Instead of using _resolutions, I'm simply using resolutions. It's now being smartcast to mutable list within the resolutions repository, which is the declaring scope. If I create the following code in my main function, passing in extra resolutions from the command line, we of course get a compiler error, as I'm sure you anticipated, clever Kotliners. The compiler is exposing resolutions with its public type, which is the read-only list interface, and that doesn't have an add member function. So let's remove that code and instead look at what we can do from this scope. So here, we are just accessing the resolutions property as a normal read-only list of strings and printing out its contents. If we run the code, we will get the following list of resolutions. There are a few things to keep in mind with this feature. The explicit backing fields type must be a subtype of the property type. In our example, you can think of the explicit backing field type as widening what you can do inside the declaring scope, as it is a mutable field. The property access modifier must be more accessible than the explicit backing field, and the explicit backing field is by default private. That too makes sense, as we want the property to be accessible from the outside scope. The property must be a val and final. We don't want to reassign or override the property somewhere else. The property also can't have an explicit get. If you are curious about the restrictions and unsupported use cases, see the link to the keep in the descriptions for a detailed explanation. The language evolution team at JetBrains tried to balance the simplicity of the feature with covering the main use cases. If you use the backing field property quite a lot, you'll be happy to know that JetBrains is bringing an inspection to auto-convert backing fields to explicit backing fields to IntelliJ IDEA in the near future. Since the feature is still experimental, the team would really love your feedback, and you can add your opinion on the feedback link in the description. So that is the explicit backing field feature in a nutshell. But before you go, have you made your Kotlin resolutions for the new year yet? What's on your list? Drop them in the comments below. Let's work together as a community to get to know this wonderful language better in 2026. That's all for now. Have a nice Kotlin.